Hello guys, I'm gonna solve the problem of centroid, but this time we're gonna include different type of materials. It's gonna be still centroid of areas, but with different type of materials. Let's copy the problem first and see what happened. Remember, this is all live. There you go. Okay, this problem is gonna be a mechanical piece like this. And right here, actually this was the original problem. It was like a hole in that part. And then when I was copying the problem, there was a class problem. Some students say, oh, that's a hole. Why don't we fill that hole with a different type of material? And then I say, okay, so you have a material here and you have another material there. So this part, let's say, is a material with a density, or not density because we are working with weights, unit weight of the material type, I don't know, B. If you say this is the type of material B, of 50 pounds per square foot. And I know this is a square foot, but it doesn't matter because we're working with areas. And the material A, let me put material A in red because I put this in red here, is let's say 30 pounds per square foot. And this is the problem that we're going to solve. Find the centroid in X and Y of this piece. Now the other thing that we need to is the dimensions, and the dimensions are as follows. This is 1.5, 3, and 3, and everything is in feet. And this is the material type A. And then you have we have the radius for the inner circle here. The radius is 1 feet. Okay, that's the problem that we have to solve. Now, how do we solve this problem? Well, we need to decompose that in figures, and as I always say, imagine that you are like going back to kindergarten, preschool, K4, whatever you call it in your country, and paper, and you have to build that piece. The only constraint that you have for building that, I'm trying to identify the number of figures and what figures we're gonna have in this problem. So the only constraint that you have here in order to build this is that you have like a pair of scissors, and then you can cut and paste everything that you want to, but you cannot paste on top of other material. Let's say that I have this material and I find this material here, and I have this square. If I wanna build another structure and put another part here, I cannot paste this on top of that. The first thing that I have to do is drill a hole, take this part out completely, and then I can replace the hole with the other material. That's what I'm meaning by that. So in this case, if you want to build that shape, we can start with this semicircular area here. Now add the other rectangular area and add the triangular area. That basically is going to give us this. And after you have that, you have to include that. Usually the students say, oh, then I put that there. And that would be partially true, but then if you just put this here, it's like pasting this on top of that, and you cannot do that. First you have to drill a hole, which what it means is extracting that piece of material B, and then you add the other material. So basically you have 1, 2, 3, 4, 5 figures, and that's the amount of figures that we're going to use in our table. So let's do that problem. our table is going to be figure area and then here is supposed to become area times this and area times that. Okay, before doing the table, let's see what type of formula we're using, and that's gonna give you an idea. Summation from I equals 1 to n of ai xi divided by the summation of ai. That is not the formula that we have to use, because if you use this formula, having that in a different material or not having it at all in a different material is exactly the same thing, because I'm just involving area. So the formula that we have to use in this case has to involve weight, and is the original formula. So the formula should be summation of xi wi divided by the summation of wi, or y bar equals summation of yi wi divided by the summation of wi. Those are the two formulas that we have to use, and based on these formulas we build the table. So I know the weight. I know the weight is function of this and is function of the area. So if I want the weight is going to be A times unit weight. It's going to be volume, but in this case we are in the plane, so we can consider unitary dimension in that way. So basically here is going to be A times 1 times unit weight. So that means that I need A, but I also need the unit weight, and then I need the weight, and the weight is going to be just area times unit weight, and then I have x and I have y and I have wi times x and I have wi times y, and then yes, I do the summation here, the summation here at the end, and the summation here, or not. No, not the summation here. I don't need this summation for anything, because what I have to do is the summation of this column here. But we're gonna go in detail one by one and see what we're gonna do. Okay, so the area is gonna be, in this case, in feet square. The unit weight is pounds per feet square. So the weight, this times this, is gonna cancel out. It's gonna be in pounds. X is in feet or foot. Y is in foot. This is gonna be pounds per foot. And if you realize, this is basically like a moment, because that's the way we derive the equation. When we derive the equation, is like the effect of that weight with reference to an axis. Okay, basically that's what we need. Let's build our table. Now we have to divide this in figures, which we did basically. So I'm going to say this is figure 1, figure 2, figure 3, figure 4, and figure 5. Those are going to be our figures for this problem. Figure 1. Figure 1 is this figure here. We have to set the axis. We haven't set up the axis. Where do you set up the system of reference, the axis of reference? We're going to set up the axis of reference in such a way that my whole figure is in the first quadrant and as close as possible as my axis, meaning this is going to be x and this is going to be y, right there. Okay, now second, I like putting my figure in this way and showing it like that, because in that way I know exactly where I have to measure it from. This is the axis, this is figure 1. Usually when I go to this part, I say, what is this? What is the area of that figure? Oh, the area of that figure is pi r squared. Okay, pi r squared. And the students start looking at this and say, oh, but I don't have this dimension. I can't solve that problem because I don't have that value. Yes, you do have this value, because if this is a semicircular area, well, this is the radius and this is the diameter, meaning the distance from here to here is going to be 2 times 1.5 or 3 feet. That's the distance. So the area for this semicircular area there is going to be pi r squared divided by 2, or pi times 1.5 squared divided by 2, and that is pi times 1.5 squared divided by 2, 3.53. You can leave this unit if you want to like that, but I'm gonna put the values. Now, what is the density of this? Not the density, the unit weight of this type of material, this part here. That's material type B. So this is gonna be 50. Now, multiplication of these two, 50 times 3.53 times 50, calculator, 176.71. And then X and Y. Okay, now we have to stop here. This is a semicircular area, and the semicircular area, somewhere in my mess here, I have the table from the book, or from most of the books. And you know what? I don't have it. Don't worry, don't be afraid. Yes, I found it. Okay, I have this table here, and this is the part where the centroid is shown. I can zoom this in. Let me see. I hope they don't mess up. You see? There you go. That's the part that we have. And the centroid is located right there. And you have the location of the centroid. Now, if you look at our figure here, and you compare that figure with this one, yes, I have the location of the centroid, but the figure is rotated like that. So be very careful when you study your centroid location. Now, this distance from the base to here is 4r divided by 3 pi, as you can read over there. Let me zoom it back. Zoom it back. There you go. Now, what we're going to do is do exactly what I did before. So you have this shape, and the centroid is located there. And this distance is 4 times r divided by 3 pi. Now, if we rotate that, and we put it exactly the same way as this is, and you put your axis of reference here, where they are, it happens that the x distance that I'm looking for is this, and the one that is given is that. Well, no big problem, because I know the distance from here to here is r. This is the radius, r, and the distance from here to here is 4r divided by 3 pi. So this distance is going to be r minus 4r divided by 3 pi. This is the only complication, which is not such thing. It's not a complication, but if you wanna find troubles, you find troubles everywhere. So this is gonna be the complication of this problem. This is r. How much is r? 1.5 is given in the problem. So it's gonna be 1.5 minus what? 4 times r divided by 3 pi. So 4 times 1.5 divided by 3 pi. This distance then is going to be, once again, calculator, 1.5 minus 6 divided by 3 divided by pi equals 0.86. 0.86. That's the distance that we are looking for here, that distance in x, 0.86. So you come here and you copy 0.86. Now, with respect to y, it's just the distance from here to here, because now the y distance, the center is located here, and as you can see, that is symmetric. What is the distance from here to here? 1.5, which is the radius. This distance from here to here is 1.5. Now you do the multiplication, w times x. Remember, we are multiplying this times x times 1 is 6.71. That's 152.6, and then you multiply these times that, and you put it here, which is 265.1. there could be some differences here because I'm using in my calculator, I'm using all the numbers, and if you multiply this times this, you might have some variation in the numbers here, but this is in the decimals, so no problem. So we are done with figure 1. Continue. Figure 2. What is figure 2? Figure 2, we call figure 2 the body, if you want to call it like that. This part, the rectangle, this is 3, and the height is also 3 because we calculated that distance, we showed that distance, 3 times 3. So our figure 2 is going to be that rectangular area, or square better say, that is here. That's figure 2. The area once again is 3 times 3 is 9. The material is the same material because all of this is material type B, so it's going to be 50, and the weight is going to be 9 times 50, which is 450. Now X, what is X and what is Y? X is the location of the centroid of the figure number 2 with respect to my axis of reference. Figure number 2 centroid, as you can see, is located at the center because that's a rectangle, if that is, or a square. If that is a square, well, the distance from here to here is going to be 1.5, from here to here, and the distance from here to here is also 1.5, so it will be 1.5 plus 1.5, which is 3. What about in Y? Well, Y is also the center, the half of the height. The total height is 3, so half of the height is going to be 1.5. Multiply this times this, 1350. Multiply this times this, 675. Done with figure 2. Figure 3, figure 3, figure 3, figure 3. Here, figure 3. We call the triangular area figure 3. This triangle here. So once again, there you go, figure 3. Now we have figure 3. The area, what is the area of that? I know this is 3 because we have it here, and the base is also 3 because it's here. So 3 times 3, 9 divided by 2 because it's the area of the triangle, 4.5. 3 times 3, if you want to put it, 3 times 3 divided by 2. Material, same material, 50. Weight, this times this. How much is this times this? 225. Now X and Y. Well, X, what is X? One more time, I repeat it and repeat it and repeat it and repeat it. So X is the distance measured in X, of course, between the system of references and the centroid of that figure, which is here. And all of you know, or should know, that when you have a right triangle here, the location of the centroid is 1/3 of the base measured with respect to the right angle. So this distance is 1/3 of the base, and the base is 3. Meaning, but remember we are measuring from here, so when you start from this axis, you are going to have 1.5 plus 3 plus 1/3 of 3, because it's 1/3 of the base. I'm gonna put that distance like that. 1.5 plus 3 plus 1/3 of 3, and this is 1, 3, 4.5, 5.5. What about in Y? Same thing, same thing. It's 1/3 because this is the right angle. If I go high, that sounded weird. If I go up, this is 1/3 of H. 1/3 of H is 1/3 of 3, which is 1. Multiplication nation, 225 times 5.5, that's 1237.5, and 225 times 1 is 225. Done. Now it comes figure 4. Figure 4. This is the figure 4. Figure 4 is a circle. What is the area of the circle? Let's put figure 4 here. My figure 4 is there. Now this material, figure 4, remember, is what we are extracting from here. So the area of this material is going of this area of this circular area is pi r squared, which is basically the radius is 1, so it's gonna be pi times 1. This is gonna be pi. And you can put here 3.14, 15, 92, 60, whatever. Now material. There's a bunch of people that say, oh, but that's a hole. If it's a hole, it shouldn't have any material. No, it has a material. Look, if this is the shape that we did, and we have to dig this hole, and you open that hole in that, the material, I don't have, my nails are too small. Well, you got the idea. If I could open this up somehow, the material that you are getting from opening the hole is the material that it was made out of, the same material, this material, and the density for this material, or the unit weight for this material, was 50. So remember, that's what you are putting here, 50. And I say something clue right now, it's very critical, because a bunch of students just put this here and forget that this is a negative area. So this is a negative area, but I'm not just gonna put negative area, I'm gonna mark the whole thing in a different color. I'm gonna get whatever I have to do, which is this, the weight, including my summation. I'm gonna put it like that. On top of that, I'm gonna put some, remember that this is negative, and I hope that you don't forget that. So weight is gonna be 50 times pi. Let's put 50 pi, cutie pi. And then feet, well, this is the easiest one because it's already given. The distance from here to here is at the center, and it's 1.5. You know the circular area, you know that, I know you know that, you're smart people. But anyway, you know the center of the circle is at the center. So this distance from here to here in x is gonna be at the center, and it's given 1.5, and in this way it's also given because it's at the center, 1.5. So this is going to be 1.5, 1.5. There you go. Every time that I say that, sounds like a Spider-Man. So 50 pi times 1.5, that's, now I'm gonna put numbers, 141.37. No, I'm sorry, what I'm doing, this is not 147, this is 50 times pi times 1.5, 235.6, 235.6, and this is the same because it's the same multiplication. Now remember, once again, negative, just in case, again, negative, don't forget that. Now we add the other figure, we're done with that one. We add the other figure, we added, and it's the same circle, or the same properties of the circle. However, this is a new material, so all the properties are going to be the same. In this case, this is going to be pi the area because it's the same geometric figure, but the material is going to be different. Look, the material for this one is 30, so we're going to put here 30, and this is going to be 30 pi, but this is going to be the same, 1.5, 1.5, 1.5, 1.5, and then we multiply 30 pi times 1.5, and that's 141.37, 141.37. What do we do now? We add. When I say we add, that doesn't necessarily mean we add. Algebraically add weight and WIX and WIY. When you do that, once again, remember, it's going to be 176.71 plus 450 plus 225 plus, no, it's not plus, right? It's minus what? 50 pi plus 30 pi, and that would be 788.9. And we do the same thing here, this plus this plus this minus this plus this, and that will be 2645.9. This plus this plus this minus this plus this, 1070.9. Basically our problem now is complete. The only thing that we have to do is apply our two formulas and say x bar is the summation of xi wi divided by the summation of wi. This value is 2645.9 divided by this value, which is 788.9, and that is calculator 0.9 divided by 788.9 equals 3.35, give or take, because of the decimal places, and the units, remember, are feet, and y bar is going to be the summation of yi wi divided by the summation of wi, which is going to be equal to 1070.9 divided by 788.9, which is the same value here, and that value is going to be 1070.9 divided by 788.9 equals 1.35, 1.36, I don't know, 1.36, let's say, fit. It's gonna be around that area. Now, after you have this, you can say, yeah, that's my result. Now, I always recommend to plot the centroid in your figure to have at least an approximate idea of if what you did is correct or not correct. Kind of, you know, it's not gonna be something precise, but definitely it's gonna help you to understand if what you did makes sense or doesn't make sense. Now let's see what happens here. 3.35, well, I know that this is 1.5 and this is 1.5 here, and then I have 3.35, meaning it's gonna be a little bit towards this side, let's say somewhere over there. This is 1.36, I know this is 1.5, that means that it's gonna be a little bit lower than this point, so my center is gonna be somewhere over there. And now you think, does that make sense? Okay, let's think about it. That makes sense. If this was completely square, let's say, it should be at the center, which is somewhere, I don't know, this is 1.5, this is 3, this is 3, 7.5, 3.75, and it's 3.35. But it makes sense that it's a little bit towards this side because you are taking this chunk of material from here. So that kind of makes sense. I don't know if it's correct, but it makes sense. And this one here, 136, is also makes sense for the same reason. It should be below because of the biggest amount of material is taken out from the top. So the bottom part should be heavier than the top part. So this location, even though I cannot say that is correct for sure, but at least makes sense in the drawing. Now I just want to discuss something really quick before finishing the problem, before finishing the video. And what I want to tell you is this: you could have combined this is only 4 figures if you wanted to when you have this type of situation, but this is like a trick, and I don't know if it's worth it saving that time, but you can do it, because if you are a little bit of let's say experienced in this, you can say, oh, but this is the same material, I just subtracting and adding, which is the same thing as calculating density. Is going to be the summation of these two. This is the one that I subtract, and this is the one that I add. So that will be the equivalent of, instead of doing these 2 sections, I could put one. I can do it like here. Let's say here. I'm going to add now to this table, instead of continuing what I was doing, I'm gonna say, oh, what I'm going to have now is this circle, and this circle is a combination of the material that I'm extracting and the material that I'm putting there. So the area is gonna be the same, it's gonna be pi, but the density, I know that the density of the material that I'm subtracting is 50, and the density of the material that I'm adding is 30. That means that the actual density of this composite type of combined material will be negative 20. And then the weight will be negative 20 pi, and this will be the same and the same, and then you multiply, you put it here. But at the end, if you realize what you are doing is that just combining these two in this, and combining these two in that, and the same thing would happen here. If you multiply this times this, 20 times pi qt pi times 5.5, that will be 20 times 20, 20, 20, 20, 20. Where are you? I don't see you. 20 pi times 5.5. 20 pi times. It will be also here the resultant of this difference, and this always also will happen here in this part. Does that worth it? I don't know if it worth it or it doesn't worth it, but it's up to you. I mean, you are saving a little bit of time. What did I say here? I say 5.5. This is wrong. Look, you know, this is live. That's what I was telling you. This is not 5.5. I was copying this. This is 1.5 here. 1.5, and this is 1.5 also. It's the same area. I'm sorry about that. I was just copying these values instead of doing this. It's 1.5, 1.5, and then I don't know if it's worth it or it doesn't worth it, but just for you to know that you can combine, and that's also applicable in the different type of problems. For example, if you have a problem like it's like that, and you want to combine only positive figures, because remember, when you do these type of problems, you could say, oh, this is a big box minus this part. But if you want to only combine positive figures, you can say that this is also built like this plus these two together, combined as a figure, these two legs, because everything is symmetric and the center, you know, is going to be at the center. Little tricks. I'm gonna do a problem like that later at some moment. So I hope that you like this video, guys. I'm doing this for you to review it and to understand the material, and really I really wish that you do good in your exams and in your life in general. Have a good day.